Time for disaccharides. And we're responsible for drawing one of 4 disaccharides here. I'm going to outline them. Celebiose is 2 glucoses hooked up, beta 1,4 in the middle. Sucrose is a glucose hooked up to a fructose, and it goes with fructose being listed first and glucose next. It's a alpha 1 to beta 2 linkage. You have it in your notes. These are just words. They don't really help. Maltose, 2 glucoses hooked up, alpha 1,4. And then the last one is, I'm having trouble remembering. We had celebiose. We had sucrose, maltose. Sorry? Oh, lactose, of course. Lactose, as its name implies, is a galactose hooked up beta 1,4 with a glucose. Okay, so you have to know how to draw those. Drawing beta celebiose. This beta is referring to not the linkage between the 2 sugars, but the one that's a hemiacetal. Okay, celebiose, the linkage between the 2 sugars has to be beta. That's not that beta. That's just what makes something celebiose. And if you really buy into the chairs, then you don't have to go looking stuff up all the time for the disaccharides. So here's my first glucose. Everything's equatorial, except maybe the anomeric linkage. And carbon 1 to be celebiose has to be beta up to this carbon of the other glucose, carbon 4. And it's beta, which means it's OH. I'm just highlighting what the beta means. It's that OH only that's the beta. The other is what's made this thing celebiose in the first place. All right. Now, the reaction of copper sulfate is an oxidation reaction of either the Fischer aldehyde or the ring hemiacetal. The acetal does not react. So I only want to show me that this thing became a carboxylic acid, not a carboxylate when it's pH 2. So why don't you save yourself a little work and make that R. You'll probably be able to use that twice. R goes to this, which comes to, I better be careful. Wow, it looks messy. No. R goes to that ring, which is not a ring anymore. So we can pretend it's a ring. That carbon we'll work on later. This thing opened up. And why I did that, I don't know. The OH is here. It opened up. That's how it became a carboxylic acid. Here's the carbon that got oxidized. It has now got a carbonyl and an OH, and there's no linkage here. There you go. And that's it. And an aldONic acid. Aldonic acid, this oxidizes and this. Why don't you do yourself a favor? You've got one oxidized already. If we're careful, call that R prime. Aldonic acid means they're both protonated. There you go. You got a carboxylic acid here in your R group and a carboxylic acid on carbon 6. And I want a diuronic acid. And I want to save a little time if I can, but I doubt it. That's one way. Now I got to be careful. There's the beta. Worked out pretty well. Diuronic acid means both of these. Diuronic acid. Well, uronic is only carbon 6. So it's not going to look pretty. That one looks prettier. Carbon 6 became a carboxylic acid in both of those. Okay. I think you find diuronic acids in things like synovial fluid. That's like the fluid between your joints to keep them fluid. I believe there's uronic acids involved there. You may correct me if I'm wrong. And I think we got that done, and hope it's been a good review day. We'll see you nice and early Monday. I'll be here at 6:30. Adios.